All right, so let's talk more about standard form. Standard form of the linear equation, as Nico told us, was ax plus by equaling c, where a, b, and c are actual numbers, real numbers, and a and b are not zero. And here's why. Consider what happens when a is 0 or b is 0. When a is 0, the equation becomes by equals c, because the a times 0 is just 0, right? So we just lose it. We don't have to have it in there. So if I were to rearrange that, I would come up with y equals c over b. And because c over b is constant, you can write y equals b. And then the same thing would happen if b equaled 0. You would have the same equation except for it'd be over a, and you could write x equals a. Okay, those are showing you whether it's a vertical line or a horizontal line. Remember, if there's no x value, then you have y equals the number. It's what kind of line? Y equals, it's going to be a horizontal line. If it says x equals, then it's a vertical line. You've seen those before already. You can see down here the reminder graphs. My face is in the way. All right, any questions about that?
Can you write the reminder graph?
Yeah, I'll give you a second to do that. All right, so let's look at example 1. So get your journals ready.
Of course, miss.
So we're going to graph y equals 4 and x equals negative 2. First of all, before we even start a graph, y equals 4, what kind of line is that?
Horizontal.
Excellent. And when we have x equals negative 2, what kind of line is that? You guys got it. All right, so you're going to draw your little quadrant. It doesn't have to be the whole thing because you know y equaling 4 is a positive number. So you can just do the kind of the top half like they did here. And then where am I going to put my dot? Yes, Nico.
On the number 4.
On which?
The y-axis.
On the y-axis. So from the origin, I'm going to count up to 4. 1, 2, 3, 4. Right here, put a dot. You see they chose a couple dots. I don't care if you pick dots. Just go over one and choose another dot and then draw your line.
Could it be any dot along the
Any dot along that line counts as your second dot. I tend to just go to the right one and call it a day.
You have to write down, like, you don't have to do a board, write down.
Nope. Label it is what you're asking. No, you do not have to label it. I mean, as long as your graph is easy for me to follow. If it looks like it's abstract, then you need to label things. All right. So now let's look at x equaling negative 2. Draw another graph. Again, you know where on the line, so you don't have to draw the whole thing. So where on which line am I putting a dot? Chloe?
The x line.
X line, and where am I putting it?
You're putting it on negative 2.
So I'm going to start at 0 and go to the left. 1, 2, put a dot. And then you can see, since we know it's a vertical line, they went up and down and chose some dots to connect their line. You guys are going, Miss Cease, we already learned this. Why are we doing it again? Because it's important to hammer it home and make sure you've got it.
How are we supposed to write down our work?
You don't have to. And on your numbers, you don't have to.
Pieces?
The only thing you would have to show your work is if you're rearranging the equation. So for these, you're not. So no work needed on your papers. I mean, if you really want to draw them just for practice, go right ahead. All right, so do monitoring progress 1 and 2. And then we'll pause there. All right, algebra. Shh. Horizontal and vertical lines. We're doing a bunch of those. You can use the fact that 2 points determine a line to graph a linear equation. We've already been doing that. 2 convenient points are where they cross the x and y axis. Because if you look over here, if I have this point and this point, it's really easy to graph it. Because you just go on the line, put a dot, go around the line, put a dot, connect them. Easy. So the x-intercept is when y equals what?
0.
And the y-intercept is when x equals.
0.
Very good. That's all you need to learn from all of this, okay? Because then you're going to be able to solve it algebraically, which is so much faster than graphing. Graphing is great. Algebra is better, in my opinion. All right. So we're going to use the intercepts to graph this equation. So that means I need the x-intercept and the y-intercept.
Yeah.
How would I find the x-intercept? You would plug 0 for y. Write this in your journals. So if I'm looking for the x-intercept, I put a 0 where the y is, and then I solve. So 4 times 0 is what? 0, so that's just gone. 4 times 0 is 0, which makes that gone. 3x, oh, they didn't show you the step.
X equals 4.
3x equals 12, so I divide by 3 to get x by itself. So 12 divided by 3 is? 4. Excellent. So that's my first intercept. X-intercept is 4. So now find the y-intercept. What am I going to do to find the y-intercept? Plug in 0 for the x. I think you got it. So then I have 4y equals 12. 12 divided by 4 is 3. So now I have my x-intercept, which is?
4.
So over on the 4, I'm going to put a dot. And then my y-intercept?
3.
So I'm going to put a dot there. And then connect them. And then you graph it. So it's a quick, easy way to graph it if it's not in slope-intercept form. If it's in slope-intercept form, I prefer to do it that way. All right, any questions on how we did that? So on your work shown, you're going to show me solving for the intercepts.
Okay, ma'am.
Yep, because that's what you're doing for the next 2 problems. All right, so now we're going to do example 3. Watch out for that desk, question mark. Okay, you are planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables fit 6 people, large tables seat 10 people. The equation 6x plus 10y equals 180 models this situation. X is the number of small tables. Y is the number of large tables. So you should have been able to build this equation without it telling it to you, because it told you how many sit per small table.
What would the small table be 1?
It's x.
Oh, X.
They just picked. It doesn't really matter. Yeah, whenever you have to do it yourself. But in this case, how many seat per small table? 6. So you're going to have 6x. And how many seat per large table?
10.
So 10y. And how many seats do we need altogether? 180. So the x and y is how many tables of each size we need. So we're going to graph it by using the intercepts. Okay?
Yeah. Wait.
This is not, nope. We're going back. We're going to do it ourselves. Because lame. All right, so.
Intercept the intercepts.
Say intercept the intercepts.
That's what it said.
6x plus 10y. Interpret.
Oh.
Equals 180. All right, so solve for x. Where am I going to plug a 0?
Y 0.
So 6x plus 10 times 0, meaning how many large tables did we get?
0.
0. We have no large tables. If we have no large tables, how many small tables are we going to get?
30.
You all agree with him?
Yes. No.
30. I'm 30
right.
for 30. I'm 30 for 30.
So if we rent no large tables, then we have to rent 30 small tables. Do you think this company has 30 small tables?
Probably not.
Probably not. All right, has everybody got that one?
Yes, I'm all barbecue.
I'm going to write it over here. X equals 30. I like the blue. All right, now if I'm solving for the y-intercept,
And plug 0 for the X.
I plug 0 for the x. So 6 times 0
I think it's
plus 10y equals 180. So that's gone.
10 divided by.
So divide by 10,
Yeah, that's 18.
y equals
Do
18.
we agree?
Do you agree?
Yes, we agree.
So if I buy no or rent no small tables, how many large tables do I need to get?
18.
18. That's more likely to be true. But if I were to graph this,
Graph time, baby.
I have graphing paper. I don't get to use my graph paper much, so I'm going to go grab it. Woo. All right. So exciting. All right, so this is my graph. It's a real life problem. We can't have negative tables, so do I need to draw the negative part of the graph?
No, you don't.
No, I don't. So we have x of 30, y of 18. So I think my x value should go up by how much?
4.
Ooh, 5. 5? 4 times what equals 30?
5.
Gross. So 5, 10. I'm going to run out of space.
No, you won't.
15, 20, 25. Ooh, you're right. 15, 20, 25, 30. Okay, and then my y values go up by how much?
4. 4. No. 2.
Could they go up?
2.
6 or 6. 6, 8. 6,
We could do another half a line in here. And then do by 2s if you want. So 2, 4, 6, 8, 10, 12, 14, 16.
18.
So 18's right here. All right, so what is my x-intercept?
30. X-intercept.
So I'm going to go to 30 and put a dot.
Yes, ma'am.
What's my y-intercept?
I would say 18.
Okay, and then what is my, so now I could connect these.
E. I assume.
Ooh, am I drawing a straight line? Not terrible.
I assume.
Not terrible. All right, so now my graph is not perfect, which is okay, but you would be able to look at a graph that is perfect and see where they cross. So like if I wanted to rent, let's say I wanted to rent 15 tables, I could go up here and say, okay, that means I need 10 of these. So you see how you could estimate, like if you're calling a company and they say, well, we only have 15 large, so you can get 15 large, whoops,
And 10 small.
and then you would get 10 smalls.
I assume.
So that's why we do a graph like that. Okay?
I get it, miss.
Any questions? I got to use my graph paper. That was fun. All right, so you guys are now doing number 5. And then you're done.
Oh, I know.
You guys were so upset about a lecture today and you have 5 problems. Come on.